Hello there, my name is John-Carlo and my role is responsible for the research of our part selection for our avoidance collision range sensor RC car. And as a fellow member myself, I've been working with various group members to develop our embedded system, in which involves the range sensor card sensing a specific object within a specific range from either the front or rear of the RC car. In addition to our embedded system, this incorporates range sensors and a motor controller, which are both used for collision avoidance. A Pi camera is also mounted on top of the RC car, which will record live camera footage. Finally, the system incorporates two front LEDs and an LDR sensor, which give an indication of the three modes: collision avoidance, normal, and auto modes.
Hi, I'm Aiden. I'm the software engineer with our team. My role was to develop the camera software for the Raspberry Pi. Our Raspberry Pi uses a network-based streaming service that you can access on any device connected to the same Wi-Fi network as the Raspberry Pi. By logging in via an IP address, you can see a live stream straight from the Raspberry Pi. So this will give us a first-person view on the top of our car.
Hello, my name is Victor, and in our embedded system design project, I'm responsible for the PCB design as well as coding, as you can see, and also troubleshooting to make sure everything is functional for our RC car. Our goal is to implement collision avoidance on the RC car. So we use the range sensors to sense the distance. Once the car approaches to an object at the front or at the back within the half meters, it will stop and go to the opposite direction.
Hi everyone, my name is Chetan Gautam and I'm responsible for testing and coding on this project. So we started our testing with putting one by one component on the breadboard and then reading their data on the serial monitor on the Arduino IDE. So I guess doing that way, we realized that early in the phase, without having to put everything together and then maybe something didn't work and then go back again, strip everything out. So doing one by one, it makes easy to do the troubleshooting. So we defined 200 centimeter being the distance where our PWM will not be activated. Anything less than that, we have defined our duty cycle to activate, gradually going 75, 50, 25, and then stop when it's less than 35 centimeter. Also, our toy car works in 3 modes. First mode is auto mode, and then second mode is collision avoidance. Third mode is just a normal mode. Auto mode being the car will work on its own without any manual input, and it will avoid the collision as it goes through, and it will go right and left as it goes through. On the normal mode, it will the user will use the steering and it doesn't have any collision avoidance integrated on it. And finally, on the collision avoidance mode, it will integrate the collision avoidance, but the input to move forward and backward will be given by the user.
Hi, my name is Kuldeep Chowda. I'm a supervisor of this project. I'll talk about prototype marketable for the devices. Like first of all, we need to identify what's the basic requirements, like Arduino, then a Raspberry Pi, a camera, so like that, and then we need to create a concept sketch, like kind of a rough sketch in a paper. We need to develop a virtual prototype like we did for the PCB, using our some softwares, and then we start making our we start making an initial handmade prototype, and then we use that initial prototype to identify and correct issues with like virtually and in reality as well.